Good morning students. Today we are going to discuss about natural consequence of total internal reflection of light. So in nature where we are going to observe the total internal reflection of light. For example, in case of desert and highways, there are water appears to be on the surface of the road and on the surface of the desert. But actually there is no water present in the desert and also on the surface of the road. So why that water appears? So why that water appears here? Due to the total internal reflection of light. Even though there is no water, but there appears to be there is a water is present. That is actually due to the total internal reflection of light. This is called mirage. Then what is mirage now? It is an optical illusion of water. Actually water is not present, but it is showing there is a water is present. That is due to total internal reflection of light. So it is an optical illusion. It is not present, but it is showing. It is called optical illusion. So it is an optical illusion of water due to total internal reflection of light. And usually mirage is observed in. It is observed in highways and deserts. See here. What is mirage now? We have to explain the mirage now. How will be the image of the tree will be formed even though there is no water present in the desert. So now let us consider. It is a surface. Now there is a tree. There is a tree in the desert. Okay, it is a tree that is present in the desert now. Now let us consider the air layer in contact with the sand here. Sand means here that is the land of the desert now. That is called sand. So it is at high temperature. Then the air layer in contact with the land here, that is also having high temperature. If it has high temperature, then its refractive index is low. So because the density is minimum, means the density is less. So if the temperature is high, we know that what is the relation between density and temperature? Density is inversely proportional to temperature. If the density is high, if the temperature is high, then the density is low. Then the air layer in contact with the land having the high temperature means it has less density. If it has less density, then its refractive index is low. Then I will take it is a air layer which is in contact with the land now. Then this air layer having the high temperature. If this air layer having the high temperature, then its density is less. If its density is less, then its refractive index is low. If its refractive index is low, now it is called which medium? Rarer medium. And I will consider another air layer which is at the high level. Okay. So this air layer having the low temperature, because this air layer is in contact with the land is at high temperature, and this air layer is also having high temperature. If this air layer having high temperature, then its density is less. If its density is less, then its refractive index is low. If its refractive index is low, then this medium is called rarer medium. Then I will consider another air layer which is at the high level from the land now. So, but its temperature is less. If its temperature is less, then its density is more. If its density is more, then it has high refractive index. If it has high refractive index, then it is a which type of medium? It is a denser medium. Okay. Then the light traveling from the top of the tree to the light traveling from denser medium to rarer medium from the top of the tree. So if the angle of incidence is greater than critical angle, the light traveling from where to where? Denser medium to rarer medium. If the angle of incidence is greater than critical angle, so then the light is totally reflected back into the denser medium. This reflected light appears to be came from below the ground. Below the ground. Here we are going to observe the image of the tree. So when we are going to observe the image of the tree, if there is only when below the tree there is a water, but actually there is no water. But that water is appears due to the total internal reflection of light. Now it is image of the tree. It is which type of image? It is an inverted image. So this optical illusion of water is called Mirage. Okay. So once again listen here. The air layer which is in contact with the land having high temperature, then its density is less. If its density is less, then its refractive index is low. If its refractive index is low, then this air layer can be considered as rarer medium. And I will consider another air layer which is at the high level from the land, and this air layer having the low temperature. If it has low temperature, then it has high density. If it has high density, then its refractive index is high. Then this air layer can be considered as denser medium. So from where to where the light traveling here? The light traveling from denser to rarer from top of the tree. If the angle of incidence is greater than critical angle, the light is totally reflected back in the denser medium. So for an observer, this reflected light appears to be came from below the ground. Then he will observe the image of the tree. So when we are going to observe the image of the tree, only when there is a water below the tree now, but actually there is no water. Means there appears to be water. This optical illusion of water is called mirage. Then there is an observer. He is an observer. So this is called mirage. Okay. So once again, on hot summer days, the land is at high temperature. The land. So the land is at high temperature. Is at high temperature. The air layer in contact with the land having high temperature. The air layer in contact with the land having high temperature, then the air layer at the heights high temperature, then the air layers at higher levels, then the air layers at higher levels. So if we are moving in upward direction, the temperature of the medium goes on decreases. As the temperature decreases, the density increases. As the density increases, refractive index also increases. Now I will consider two air layers here. One air layer is in contact with the land, that one having the high temperature, and another air layer having the low temperature. The air layer having the low temperature is called denser medium, because low temperature means high density. High density means refractive index is high. Then the light traveling from denser to rarer from the top of the tree. So if the angle of incidence is greater than critical angle, the light is totally reflected back in the denser medium. So this reflected ray appears to be came from below the ground. Then the observer can observe the inverted image of the tree as the image formed in the pond of water. Okay. So this optical illusion of water is called mirage. Air layer in contact with the land is less dense. is less dense, means density is less. Air layer in contact with the land is less dense. Why it is less dense here? Because of its high temperature. If it's high temperature, then its density is low. Okay, less dense than the air layers at the higher levels. Than the air layers at the higher levels. Higher levels. Okay, higher levels. Then, when a ray of light traveling from denser medium to rarer medium from the top of the tree, when the angle of incidence is greater than critical angle, the light is totally reflected back into the denser medium. This reflected ray will be appears to be came from below the ground or below the land, means the observer can observe the image, inverted image of the tree. So as it is formed in the pond of water. When a ray of light traveling from which medium to which medium? High refractive index medium to low refractive index medium. From denser to rarer medium. From the top of tree. From the top of tree. From the top of tree. When the angle of incidence is greater than, when the angle of incidence is greater than critical angle. Is greater than critical angle. Then the light is totally reflected back into the denser medium. Then for the observer, this reflected ray appears to be came from below the ground. Then the reflected ray, then the light is completely or totally reflected. Totally reflected back to the denser medium. Back to the denser medium. So for an observer, this reflected ray appears to be came from below the ground. For an observer, this reflected ray appears to be came from below the ground. Came from below the ground. Then the observer observes the inverted image of the tree as it is formed in the pond of water. Actually, there is no water. This optical illusion of water due to total internal reflection of light is called mirage. Okay, so it is very important how will be the mirage is formed. Okay, so this is about mirage. Now, applications of total internal reflection of light. So, what is the first application here? So, means why the diamond sparkles brilliantly. So, what is the cause of the spectacular brilliance of diamond? That is total internal reflection of light. Already we know that what is the refractive index of diamond? That is 2.42. And what about critical angle? Its critical angle is 24.4 degree. So, diamond is cut in such a way that as the light falls on the diamond, the light undergoes multiple total internal reflection of light. Then this causes the diamond sparkles brilliantly. Means the diamond shines brilliantly. So, refractive index of diamond is 2.42 and its critical angle is 24.4 degree. Already we calculated what is the critical angle for diamond, glass and also water. Okay, so the refractive index of diamond is 2.42 and its critical angle is how much? 24.4 degree. So the diamond is cut in such a way that means the diamond having the particular shape. As the light falls on the diamond, the light undergo multiple total internal reflections. Hence, the diamond sparkles brilliantly. The diamond is cut in such a way that so that is why the diamond having the particular shape. As the light falls on it, the light undergo multiple total internal reflection. Why? Because here, however the light falls on the diamond, here the angle of incidence is greater than 24.4 degree for the diamond. Then the light undergo multiple total internal reflection. This causes the diamond sparkles brilliantly. So the diamond is cut in such a way that as the light falls on it with an angle greater than critical angle. As the light falls on it, the light undergo multiple total internal reflections. This causes the spectacular brilliance of diamond. And this question will be asked as why the diamond sparkles brilliantly. Okay, so why the diamond sparkles brilliantly here? Because what is the refractive index of diamond? Refractive index of diamond is 2.42 and its critical angle is how much? 24.4 degree. Then the diamond is cut in such a way that as the light falls on it, that light undergoes multiple total internal reflection. As the light undergoes multiple total internal reflection, then the diamond sparkles brilliantly. Okay, what is the cause of the spectacular brilliance of diamond? That is nothing but total internal reflection of light. Once again, what is the cause of spectacular brilliance of diamond? That is total internal reflection of light. However, the light falls on the diamond, here the angle of incidence at the interface of diamond and air is greater than its critical angle. The light undergo multiple total internal reflections. Okay, so this is about spectacular brilliance of diamond. Second one, total reflecting prisms or total reflection prisms. And these total reflection prisms work on the principle of total internal reflection of light. Then what are the total reflection prisms? So the total reflection prisms are the isosceles right-angled prisms. So which are used to bend the incident light by 90 degree, 180 degree, or to get the erect image of the inverted object. So what are total reflection prisms here? These are the isosceles right-angled prisms. Used to turn the incident beam of light. by A 90 degree, B 180 degree, C or C to get the or to obtain the erect image of inverted object. Erect image of inverted, to get the erect image of inverted object. Now, how will be this total reflection prism will be turn the light by 90 degree, and this arrangement is used in which device? Okay. How will be this total reflection prism will be turn the light by 180 degree, and also how will be this total reflection prism used to obtain the erect image of inverted object. So let us discuss one by one by the ray diagrams. Now see here. This is an isosceles right-angled prism. Already you know that what are the isosceles right-angled prisms. Now let us consider this is an incident beam. Here the light falls on how the light incident here? The light is incident normal to this surface. Then it passes without any deviation. But this light falls on this surface now. This is the interface between air and denser. Means the glass is the denser here and air is the rarer. Means denser to rarer interface. Okay. It is called denser and rarer interface. So here the angle of incidence is greater than critical angle, because what is the critical angle for the glass? Critical angle for the glass is 42 degree, but here the angle of incidence is 45 degree. It is how much? 45 degree. And it undergo reflection, because the angle of incidence is greater than critical angle. What is the critical angle for the glass and air interface? That is 42. But here angle of incidence is 45, it is greater than critical angle. The light is totally reflected back, and this reflected light is normal to this surface. It passes without any deviation. Okay. And also here the angle of incidence is greater than critical angle. Again the light undergo total internal reflection in the prism. So here the light bent by what angle? The light bent by 90 degree. See, it is 45, it is 45, 45 plus 45, that is how much? 90 degree. Here also it is 45, it is 45, 45 plus 45, it is how much? Again 90 degree. Then here the incident beam is turned by what angle? That is 90 degree. And this arrangement is used in periscope. This arrangement used in telescopes. Used in periscope. This arrangement is used in periscope. Okay. So now this is about the light turned by what angle? 90 degree. Supposed to be. Again it is a isosceles right angled prism. Then we are going to consider the incident beam. It is an incident beam. Okay. Here the light traveling from which medium to which medium? Rarer to denser, but it is how it is incident? It is incident normally. So if the light falls on the interface of denser and rarer, with an angle greater than critical angle, the light is totally reflected back. And this reflected ray is incident ray for the second surface. Okay. And again here the angle of incidence is greater than critical angle, then the light totally reflected back. The light is totally reflected back. So by what angle the light is turned here? That is by 180 degrees. Here 90, total angle turned. Sorry, what is the total angle turned here? Total angle turned is how much? 180 degree. And again I will consider another ray. These rays are coming from the object. And again at this one point, the angle of incidence is greater than critical angle, again the light undergo total internal reflection, and this totally reflected light is incident ray for the second surface. Again here the angle of incidence is greater than critical angle. Again the light is totally reflected back. Then here, by what angle the light is turned here? By the 180 degree. Then this arrangement is used in binoculars. Binoculars. You heard about binoculars. Next one, the right angled isosceles prism is used to get the erect image of inverted object. So how? See here by the right angle. Now this is inverted object. Inverted means already you know that the head of the object is downside. Then the ray coming from the base. The ray coming from the base, it falls on the surface. The light undergoes refraction, and as it falls on this surface now. Then here the angle of incidence is greater than critical angle. The light is undergo total internal reflection. And this reflected ray passes from where to where? That passes from prism to air. Then it bends away from the normal. So this is the ray from base of the object. Next, the ray from head of the object. It falls on the, again this interface here. Here the angle of incidence is greater than critical angle. The light is completely undergo reflection. This reflected light falls on the second surface of the prism and it undergo reflection, and this reflected ray appears to be came from which point? That appears to be came from head of the inverted object. So this ray from head of the inverted object and this ray from base of the inverted object. So where will be the head is formed here? Head will be formed here. It is head and it is base, because this ray from base of the inverted object and this ray from head of the inverted object, we will get the erect image of the inverted object by the total reflecting prisms. So this is about the applications of total internal reflection of light, and one more application is there, that is optical fiber. Okay, we will discuss about optical. Third application, that is optical fiber. Already we discussed that the brilliance of diamond, that is due to total internal reflection of light, and on which principle total reflective prisms work here. So on the principle of total internal reflection of light. The total reflective prisms are used in periscope binoculars, and also it is used to see the erect image of the inverted object. Already we discussed that. Now we are going to study about the third application of total internal reflection of light, optical fiber. So what is an optical fiber? Optical fiber is a transmission medium used to carry the optical signal without loss of energy. Okay, so optical signal means light signal. What is optical fiber? Optical fiber is a transmission medium, means which can be used to transmit the optical signal in the desired length, means a desired path. So optical fiber is a transmission medium used to carry optical signal. Optical signal without loss of energy. Without loss of energy of the light. Without loss of energy. Then on which principle optical fiber works here? Optical fiber works on the principle of total internal reflection of light. Even what is the cause of spectacular brilliance of diamond? That is also total internal reflection of light. And on which principle the total reflective prism work here? So the total reflective prism works on the principle of total internal reflection of light. And also optical fiber works on the principle of total internal reflection of light. Now we are going to study about construction and working of the optical fiber. Construction means what are the essential parts of the optical fiber? Means main parts present in the optical fiber. So a thin optical fiber is made up of glass or quartz of high refractive index and it is called core. And this core is coated with a less refractive index material that is called cladding. Core and cladding. Core having high refractive index and cladding having low refractive index. So optical fiber is a thin fiber. Its thickness is about 50 micrometer. Thickness of the optical fiber, it is about 50 micrometer. Just imagine what is the thickness. It is very small thickness. Because 50 micro is 10 to the power of minus 6 meter. Means optical fiber is very thin device. Optical fiber is a thin fiber. Is a thin fiber made of glass, or because glass is a transparent medium, or quartz of high refractive index, and is known as core. So it is the essential part of the optical fiber. And one more essential part is there. For the total internal reflection, the light should be traveled from high refractive index medium to low refractive index medium. Then this core is coated with a material having low refractive index. The core is coated with low refractive index material. The core is coated with low refractive index material is called cladding. These are the two essential parts of the optical fiber. What are those? Core and cladding. Okay. Among the core and cladding, which is the denser? Core is the denser because it has high refractive index, and cladding is the rarer because it has low refractive index. Then how it works? Working of optical fiber now, how it works? So we know that the optical fiber is made up of glass and it is very thin in size. It is about 50 micrometer. So optical fiber is a thin fiber made up of glass or quartz of high refractive index. This is known as core, and this core is coated with a low refractive index material that is called cladding. So we have to draw the diagram by using core and cladding now, by using the concept of core and cladding. Now, this is called core and this is called cladding because this cladding is a material which is coated to the core. Then, the core having high refractive index, the cladding having low refractive index. Means core is the denser and cladding is the rarer. So, this shaded is nothing but it is coated material which is coated to the core. Now it is cladding. This cladding having low refractive index. It has low refractive index. Then it is a rarer material. Then now this is core, and this core having high refractive index. So a ray of light enters through one end of the optical fiber is incident at an angle greater than critical angle. The light undergoes multiple total internal reflections in the optical fiber and emerges out through the other end without any loss of energy. See here, what is the ray diagram for that one? The light incident means the light traveling or the light entering through one end of the optical fiber is incident at an angle greater than critical angle. Here the angle of incidence is greater than critical angle. The light is totally reflected back into the core. Core is the denser. Okay. So this reflected ray is incident ray for the next point of incidence. Again here the angle of incidence becomes greater than critical angle. Again the light totally reflected back into the core. Core means here denser area. And this reflected ray is incident ray for the next point of incidence. Again here the angle of incidence is greater than critical angle. Again the light is totally reflected back into the core. And this reflected ray from this point of incidence is incident ray for the next point of incidence. Okay, again it undergoes total internal reflection. So see here, for every point of incidence, the angle of incidence is greater than critical angle. Then here, for this point of incidence, again the angle of incidence is greater than critical angle. The light is emerges out through other end of the optical fiber without loss of any energy. So it is the working of optical fiber. Here the light undergoes multiple total internal reflections. Number of total internal reflections. A ray of light entering through one end of the fiber. Fiber means here optical fiber. One end of the fiber, a ray of light entering through one end of the fiber is incident at an angle. Greater than critical angle. At an angle greater than critical angle. Critical angle for the given pair of media. What are those pair of media? Core and cladding. Critical is incident at an angle greater than critical angle. Then the light or then the ray undergoes multiple total internal reflection. Multiple means the number of total internal reflections. See here, first, second, third, fourth, fifth means how many total internal reflections in the diagram? 5 total internal reflections. These are called multiple total internal reflections. Is greater than the critical angle. The ray undergoes multiple total internal reflections and emerges out through other end. Means comes out through other end. Emerges out through other end of the fiber. Through other end without loss of energy. So this is working of optical fiber. Then what are the uses of optical fiber? So first use is that optical fiber is used as a light pipe to examine the internal organs of the human body. Okay. If we are going to see or if we are going to examine the internal organs of the human body, we are going to use the optical fiber. Here, optical fiber is used as a light pipe to examine the internal organs of the human body like intestine, esophagus. Okay. So next, what is the next use of optical fiber? Optical fibers are used as decorative lamps, and also optical fibers are used in purpose of communication. These are some uses of optical